One last item you want to care about is how traffic flows when you do all this roaming. This is going to sound strange, but keep in mind that in a normal choreography, most of your roaming is going to happen within an SPG. That's how you design a network, and this is why you designed it that way, because you knew that roaming would be fast and frequent there. And if you have two SPGs, you know that sometimes roaming may happen between these two, but that is not going to be either frequent or very critical in terms of efficiency. And roaming between mobility groups is even less frequent. So as long as you are in the same SPG, your traffic is going to try to stay in converged access at the same MA level. That is to say, we're going to encapsulate traffic from one MA to the other so that your point of presence doesn't move. Your POA, of course, follows you as you go, but the POP, unless you configure the system, otherwise, if you keep the default, your POP is not going to move. It's going to stay on the first controller. Now, what is strange is that if you move from one SPG to the other, then your traffic will still stay on the first MA, so your POP is going to stay as well. But because now we involve the MC, traffic will actually flow through the MC. That doesn't look very efficient, does it? But again, keep in mind that this is not supposed to happen very often. Most of the time, you're in the SPG, and if that roaming happens often, then your design is wrong. You need to redo it. We want to go through the MC that, by the way, has a different name in that case. It's called the Mobility Tunnel Endpoint, MTE. But if that happens very often, then you have to redo your design. We go through it because we want to maintain traffic flowing and managed by the mobility controller, but that's an occasional roam. So what about if you roam between mobility subdomains? Well, the same happens with just one more MC in the play. Your POA follows you just as usual, and we try to keep your POP at the same location as usual. But now, because there are two MCs, you have to go through two MCs, and because it's about data flow, actually their name in that case is MTE, Mobility Tunnel Endpoint. But again, that's not important. You can keep the term MC in your mind. Traffic will have to go through these MCs. Again, not very pretty, but that should be very occasional. If that roaming scheme happens often, then your design is wrong. You should put these guys in the same SPG under the same mobility controller. The same, by the way, would happen if these two controllers were in different mobility groups, right? You will have to re-authenticate, but we'll keep the same mechanism where we try to maintain your POP at the same location. So that's true for within and between mobility group roams. Of course, the exception is if you have to re-authenticate entirely, and if you start a new session, then you may move entirely to a new session that will be only on the right side. But if you maintain your IP address, if you maintain your awareness in the first group, then your traffic will be encapsulated and will stay at the same POP. This is in the converged access logic. What about the ROS? Well, in the ROS, the MC and MA is in one single location. So in fact, what happens is exactly the same, but you bring the MA and you put it inside the MC, and you see the same choreography, except that instead of having an MA talking to the MC, it's one single box, so the communications is internal. There is nothing going outside. But the traffic flow is going to be exactly the same, just going through the MC all the time because the MC is always there. There is no SPG concept anymore, so you can drop this area. And because there is no SPG anymore, there is no subdomain anymore, but there is still the notion of mobility group and of course the mobility domain. And roaming is going to have the same choreography as before, except that it's going to cross the MCs instead of sometimes being maintained at the MA because there is no MA anymore, so the MC has to be involved all the time. But logic is the same. And the terms are always the same as well. Layer 2, foreign to local, local to foreign, layer 3, all those are exactly the same from one architecture to the other. The only difference really is that the ROS simplifies the choreography because you drop the SPG layer, you drop the MA layer, and you bring everything at the MC layer.